When capacitors are in parallel, like shown in this circuit here, the charges from the negative lead are going to be divided among both capacitor plates. So negative charges from here are going to move to here and to here, such that the overall charge coming out of the battery is going to be equal to the charge going to the first capacitor plus the charge going to the second capacitor. This is the relationship. If we had 3 or 4 of them, we'll have the charge will be divided among the 3 or the 4. Now, the negative charges here, Q2 here, is going to repel the negative Q2s here, leaving a plus Q2. That's going to move to the positive lead of the battery. And the negative Q1 here is going to repel the negative Q1 here, leaving a positive charge of plus Q1. The negative Q1s are going to be pushed towards the positive lead of the battery. Now, the capacitance equation for both of them still applies. Q2 is equal to C2 delta V, and Q1 is C1 delta V. We have the same delta V since they are connected in parallel. And you see the wiring illustrates that. Here we have a conductor all the way from here to here. That's why we see it all red. And here we have the same electrical potential wherever we see all orange. The potential difference between orange and red is the potential difference across C2, it is the potential difference across C1, and it is the potential difference across the battery. It's the same potential difference throughout. That's why we have the same delta V here. Now, when we write the equation Q is equal to Q1 plus Q2, we replace those here. C1 delta V plus C2 delta V, we end up having C1 plus C2 delta V. So if we replace these two capacitors by an equivalent capacitance, we are again going to get the equation Q C equivalent delta V. That tells us, comparing these two expressions, that tells us that the equivalent capacitance of two capacitors when they are in parallel is C1 plus C2. Let's summarize the results for both series and parallel. For a series capacitor, the voltage across the battery is going to be divided among the capacitors, and the amount of voltage, delta V2 and delta V1, can be found as Q over C2 and Q over C1. The charges are going to be the same in all capacitors, in all series capacitors. The voltages are going to add up. The voltage across the battery is the voltage across C1 plus the voltage across C2. And we find the equivalent capacitance by adding the inverse of each of the capacitors. That's for series. For parallel, same voltage across all capacitors in parallel. The charges are going to be divided among the capacitors such that the charge coming out of the battery is going to be the sum of the charge in each of the capacitors. And the equivalent capacitance, we get it by a simple sum of all capacitors.